lecture, we are going to discuss the design requirements. In the previous lecture, we discussed the steps in the design process. And we said that the first step should be defining the problem, which means that I need to ask a couple of questions to clearly know what is the problem is. So I need to know exactly what is the problem. I need to know who has a problem, and I need to know also why is it important to solve the problem. By doing this, I'll be able to clearly define the problem. Then I need to do background research. I need to look at the previous solution for the problem. I need to ask the customers, I need to ask engineers who work on a similar project. And also, I need to know their mistakes so that I'm not going to repeat their mistakes. I'm going to avoid their mistakes. Then I'm going to specify the requirements. The requirements, it could be about the safety. How much safety do you want? Or it should be about the functional requirement. What is the purpose of your solution? And also, I need to know data about the solution. For example, how much load on the building, or also I need to know whether you have snow or earthquake and so on. So I need to gather information. So I need to know the requirement about the data and information. And also I need to know about the economy, how much you are willing to spend on that solution. And also I need to look at the sustainability requirement, whether your solution is going to hurt the resources of the earth or not. Also, I need to know what type of codes should be used. So it's important to specify the requirements. And in today's lecture, we are going to talk about the design requirements in great details. And of course, then after I specify my requirement, I need to make brainstorm, which means that I'm going to come up with possible solution as much as possible. Then I'm going to evaluate each and every solution, and then I'm going to choose the best solution. Then how I'm going to choose the best solution? The best solution is going to meet more requirements than the other solution. In the brainstorm step here, we generate many solutions. Then the best solution is going to meet more requirements than the other solution. Then after I identify the best solution, I need to develop the solution, which means that I'm going to enhance the performance of my solution. And also I'm going to make a model or prototype. When I made a prototype, I'll be able to test my solution. I need to test my solution to make sure that my solution is going to meet the requirements. Then I'm going to end up with two possibilities. Either my solution is going to completely meet my requirements, and in that case, I'm going to communicate my result. I'm going to show my result in terms of the documentation, engineering drawing, reports, and so on. The other possibilities is the solution is not going to meet my requirements or partially meet my requirements. In that case, based on the results that I have got, I need to go either to this step or that step or that step. Depends on the result. So it depends on the result, either to start from here or from there or from there. And in today's lecture, we are going to talk about the design requirements. Then I'm going to ask a question. Do you think the design requirement is going to be the same for every project? The answer is no. So the design requirements for your projects will differ from those of anyone else. Why? Because you are going to apply your specific solution for the specific problem. For example, here we have a hospital and here we have administration building. Even though they look identical from outside, but the requirements for the hospital is going to be different than the requirement for administration building. For example, the safety, the radiation safety here, I need to provide radiation safety for hospital, whereas in the administration building, it's not required to do that. Also, the safety for the hospital, it should be higher than the safety for administration building. Also, how much you are going to spend on the hospital, of course, is going to be much than the administration building. So even though here we have identical building from outside, but the design requirements is going to be different from this building to that building. So your requirements will be more specific and directly related to meeting the needs of your project's users. Okay, so here your the users of the hospital building, they need radiation safety, but in the administration building, they are not going to have something like that. So the bottom line is the design requirement is going to be different from one project to another. So we need to know the design requirements is going to be about what. So the design requirements is going to include the safety. How much safety you want to implement in your project. For example here, because the hospital is important, more important than the administration building. So here I'm going to put a larger factor of safety, more than the administration building. So safety is one of the design requirement and is going to be different from one project to another. Also the functional requirement. For example here, what is the purpose of the hospital? We need to serve the patients. While here we need to serve the customers. And here we need to provide room with special equipment in order to cure people. Or here we need to have service that to serve the customers. So also the functional requirement is going to be different from one project to another. Also we have the serviceability requirements. This requirement like how much comfortable do you want in your project. For example, we have limits on the cracks on the building. Every building is going to have a cracks, but we have limits on that. For example, it's not going to be acceptable to have a larger crack in a hospital building, but sometimes it may be acceptable to have a certain crack in administration building. So serviceability, it means that the building is going to perform properly, but there is limitation has been exceeded. Also, we have the data and the information. The data and information, I need to know how much load on the hospital, and also I need to know how much load on the administration building. So the load here is going to be different from there. Also, if let's say that if that hospital is located in Canada, so in that case we are going to have snow load. And also, if the hospital is located in a region where you have high intensity of the earthquake. So in this case, you need to design for earthquake. Again, you are going to have differences. You could have hospital here in this city and hospital in cold region, even though they have the same functional requirements, but when it comes to load and information, you are going to notice differences. Also, we have the economy, how much you are willing to spend on the project. It's a very important question because depends on that, I'm going to choose certain materials, certain equipments, certain contractors, certain quality assurance. Depends on how much money you are willing to spend on your project. Also, we have the sustainability requirements. We need to determine how much the building is going to be friendly with the environment, how much you are going to hurt the environment or not to hurt the environment. Because in sustainability, we need to make sure that we are going to use resources in a way that is not going to affect the next generation. We have limited resources on the earth, so we are not willing to waste all the resources, because the next generation, we are not going to find anything. We have the codes and the specification. So we have codes. The codes and specification help us to regulate our work and provide standards for your project. So you need to have which code and specification should be used for your project or your solution. Finally, we have the environmental impact. We need to know whether your solution is going to affect the environment or not. For instance, regarding the hospital is going to discharge medical wastes. So I need to have a plan how to deal with that. And also, because many equipments here is going to release radiation, also you need to have a plan to deal with that. So I need to consider the environmental impact, and again, it's going to be different from one project to another. So now let's look at the first design requirement, the safety requirement. How to provide safety for your structure. Okay, so those who took reinforced concrete design, they are going they went through the process of design under worst possible loading scenarios, which mean that you are going to have combinations. You have various load combination. It should be examined to find the worst case. You have dead load, you have live load, you have wind load, you have snow load. So you need to make combination. It depends on the situation. You need to make combination so that you are going to come up with the worst possible loading scenarios, so that whatever happened, your building is going to be safe. And the load combinations are known for the most design. So before you start designing a building, you need to work with the load combinations so that you are going to get the worst possible loading. And why we are going to do that? In order to provide more safety. So how much safety do we want? It depends on the situation of your building. Again, the safety is going to be different from one project to another. Also, we have the functional requirement. Every structure should have a purpose, right? Every structure should have a purpose. So we need to have the purpose of the structure. And we should meet all the functional aspects. We should satisfy all the functional aspects of your project. For example, let's say that we need to construct a library. So in order to construct a library, I have functional requirement. We have purposes for what we want to build a library. For example, we need to have entrance, lobby. We need to have reading rooms because this one is the library. We have to have auditorium. We need to have also a space for books and shelves. We need to have offices. We need to have lighting, acoustics, and parking. So if I'm going to construct a library without reading rooms, in that case, I'm going to miss one of the most important functional aspect, which is not acceptable. So if I'm going to construct a library, it's important to meet all the functional requirements. It's not acceptable to miss any of these requirements. And of course, it could be extended for any example. For example, if you want to manufacture a car, for example, also you are going to have different functional requirements. So we need to make sure that we are going to satisfy all the functional requirements for my project or for my solution. Also, we have the serviceability requirements. So serviceability requirements in civil engineering and structural engineering refer to the conditions under which a building is still considered useful. So a structure that may still be structural sound, which means that I can use the structure without any problem, but it's going to be considered unfit if they exceed some limits, such as deflection, sway, deformation, and cracking. We know that here we have simply supported beam. If we are going to apply a force here, we are going to have deflection. But we have a limit for that deflection. If we exceed that limit of the deflection, in that case, the structure is going to consider unfit, even though the structure can take the load. So the structure can take the load, but here we have deflection. And if that deflection exceeds a certain limits, then we are going to consider the structure to be unfit. That's what it meant by serviceability requirement. For example, here we have a pavement, right? We have asphalt concrete here for that road. Even though that road is going to help the cars in order to go from one point to another, but here we have pavement cracking, we have cracking, and we have rutting. So that level of rutting and cracking is not acceptable. Okay, so in this case, we are going to consider that road to be unfit, but it can take the load. Also in the building, we are going to see cracks. Every building, it has a cracks, but maybe the crack is very small. So if the cracks exceed a certain limit, then we are going to say that this building is unfit to be inhabited, even though the building can take the load without any problem. And we need to determine the serviceability requirement for your project. You need to know, you need to determine the limits for your deflection, sway, deformation, and cracking. Which one is acceptable for you and which one is not acceptable for you. Here we have that building in Fukushima in Japan, an earthquake with a magnitude of 8.5 in Richter scale hit that building. Like you can see, that point it was here. But because of the earthquake, we are going to have sway. So you can clearly see the sway here in the picture. So even though now the building can take the load, but this magnitude of the sway is not acceptable. So we are going to say that this building is unfit. Also for the roads, I'm going to have something like that. The rotting here, we have a high level of rotting. So in this case, we are going to consider the road to be unfit. So we need to have maintenance. I hope the serviceability requirement is clear for you. Also, we have the data and the information. Of course, if you are willing to come up with any design, you need to have the right data for that. Otherwise, you'll not be able to complete your design. For example, you need to know the loads. You need to know how much load on your building. You need to know the environmental factors. For example, maybe your solution is going to be used in hot region or cold region. So that is going to affect your design. Also, some projects, it has a specific requirement. For example, if you want to construct nuclear facility, you are going to have special requirements. And also I need to know the materials that can be used and their sources. You could build, you could construct your building from, for example, from the steel or from concrete or from wood. So which one you are going to use and how you are going to get the source of your material. So I need to know all this information in order to design my solution. And those is going to be different from one project to another. Also, we have the economy. Economy, one of the important requirements. Because in the design, we should consider the materials and the method that can produce economic design. So, for example, I don't need to use expensive material that's going to cost me a lot. And also, I'm going to use a method make the design economic. Sometimes, for the name of safety, because of the safety, some engineers, they are going to over design the elements. They are going for put a lot of steels, larger thickness in the name of the safety. As engineers, we are trusted to save materials and the cost. Do not use something that is not needed in the name of the safety, because that is going to cost the owners a lot of money. Of course, your building should be safe, but it should not cost a lot of money. So you have a balance between the safety and between the economy. The good engineer should design the solution with a good level of safety, but also with a reasonable amount of money. You should not take a lot of money from the owners, okay, in the name of safety. Your project or your solution should be safe and also should be economical, okay. So good engineer should do that. Also, we have the sustainability. Nowadays, everyone talk about the sustainability. So sustainability is defined as a requirement of our generation to manage the resource base such as that the average quality of life that we ensure ourselves can potentially be shared by all future generations. We have resources right now, and we consume a lot of that resources, which is not renewable. It means that the next generation will not going to get benefit from these resources. So we should keep the resources so that the next generation, those will come after us, they are going to enjoy the same luxury that we have enjoyed right now. So the philosophy of designing physical objects, build facilities and services to comply with the principle of economic and environment and social issues. So sustainability, it should be the intersection between the economy and environment and society. We need to come up with solutions that satisfy the economical needs and environmental needs and the society needs. One of the principles of the design, the structures should have a long life. So one of the sustainability requirements, your structure should have a long life. And also you need to use durable materials and products for sustainable design. So one of the sustainable requirements is to use durable materials and the product, and your structure should have a long life. The famous design motto is design or build to last. Okay, you need to build something that can last for many years. And also your building should not consume resources which is not renewable. Okay, because if you are going to use non-renewable sources, then the next generation will not get anything. And also we have the codes and the specification. Every and each design should follow a recognized code or codes. Usually it could be local codes. If available, that is going to be better, because the local code is going to consider the local conditions. Also, we have regulation. Building regulation should be followed. For example, here in the municipality, if you want to have a license to build something, you need to go to the municipality and you should meet the building requirements from the municipality. For example, here in the city, it's not allowed to build more than 3 floors. So you need to meet these regulations. So we have the codes and also we have regulations implemented by the authority of your city. So what is the code? The code is going to provide guidelines and requirements for the design and detailing which are to be followed by all. They are codes for different designs. We have codes for concrete structure design. We have codes for steel design, for pre-stressed concrete, for welding, offshore structure, bridges, dams, and towers. So if you are going to construct towers, they have their own codes. If you want to construct bridges, they have their own codes. So we need to follow the codes so that we are going to have guidelines which has been followed by all. You are not going to make something by your own. You need to do like the rest of the engineers. Finally, we have the environmental impact. Many projects or solutions that are going to have bad effect on the environment, like the pollution. For example, if you want to construct industry or something like that, so in this case, you are going to have pollution. Are going to have pollution or sometimes contamination. So some factories, they are going to discharge toxic materials to the environment, to rivers and seas. So that is adverse effect. Also, we have a solution that is going to make a lot of noise for us, like airplanes, like cars. And sometimes we come up with solution with health related issues. We have many projects or products with health related issues. And sometimes we have a solution with ecology problem. Ecology means the interaction among organisms and their environment. For example, if you want to construct a dam, the dam is going to affect the interaction between different animals and different organisms. And also sometimes they are going to change the how much rain is going to be applied to a certain area. And also sometimes some solution is going to create social problems. So we need to make sure that our products and our solution is not going to have bad effect, like the pollution, contamination, noise, health-related issues, ecology, and social problems. So here we have factories with pollution. Those factories is going to release CO2 to the environment. Here we have products. They are in terms of waste materials. Also, they are going to hurt the environment. Here we have dam. The dam, we say that it could make ecological problems. And here we have offshore oil platform. Maybe a leak of oil is going to contaminate the river or the sea. Here we have cars and we have airplanes that are going to provide noise, which is not good for us. So we need to take care of the environmental impact. Here we have a factory that is going to release toxic materials to the river. So we need to go green. The last point about the design. I'm going to stop here. If you have any questions, please ask me.